So this is a little bit about me. My name is Tom Richards. I'm a security consultant at Citadel. We are a silver sponsor here. We were a silver sponsor last year too, so yay us. There's my Twitter. If anyone wants to follow me, that'd be cool. Sometimes I tweet stuff. And took the offensive security certs, the OSCP, the GPAN, I had that too, and then the OSWP, that's for the wireless stuff. I developed a GUI file and a Polarization. Polarization is definitely depreciated by now, because that was like based off the first iteration of Debian for the Raspberry Pi. The GUI file has been in Backtrack since R2. It's been included in the main distribution. It allows you to query Google for the domain and a file type and pull out like different file types. So a little cool thing if you're doing information gathering on a target. I'm also one of the organizers for B-Sides Rock, which is a conference we have up in Rochester, New York. And I've given talks both here and DerbyCon the past 2 years. This is my second year speaking here. So I really appreciate you guys coming back out. And I really enjoy taking part in Android. So in this talk, we're going to go over what Dalvik is. Then we're going to have a little opcode primer, how to read the small E files once they're extracted from APK. And then I got a couple case studies for you to kind of put what we learned into practice. Alright. So what is Dalvik? First, it's a title in ISO. When you Google Dalvik, it's the first thing that comes up. What it means, what is in our context, is a lightweight, register-based virtual machine that runs on Android phones. And it's been optimized for the embedded mobile platform, so it's designed to run with low RAM and low CPU capabilities. Some of the optimizations that they use, duplicate code to achieve being able to run in the low resources. Some duplicate code is reused within the code. They have a 16-bit instruction set that works directly on local variables. And then it also lowers the instruction count and increasing interpreter speed. Yay! So this allows it to run in less space compared to like this traditional Java VM. Okay. So when I say Dalvik is register-based, the normal Java VM is stack-based. And think of it like a program. Well, like x86 assembly is stack-based, right? x86 is stack. So you push your hot variables off the stack. Where in Dalvik, there's actually like registers that hold the variables that you can assign values to. So you're not pushing popping off the stack, you're more or less assigning to a variable in there. Here's an example of the difference between stack and register-based. So on the top here, this is stack-based, so this is Java bytecode I took out. And then down here is the Dalvik. So you can see the difference, they're not the exact same pieces of code, but you can see the difference of the code, how the bottom one is way easier to read in my opinion than to try and read straight Java bytecode. Alright, so how do we get to Dalvik, right? Android apps are traditionally written in Java. They can be written in C, C++ as well. After you write the Java app, the compiler will take the Java code, compile it into Java, and then convert it into the Dalvik bytecode before it's packaged into the APK. And these are stored as .dex inside of an APK file. Here's a quick little diagram that shows the differences between what happens when you compile Java for normal Java VMs and when you compile Java for a Dalvik VM. And there's the middle step I was talking about, how it then takes the Java bytecode and converts it to DEX, and then it gets packaged up. If you just unzipped an APK file, just took it and unzipped it, you would end up with these files. The Android manifest, which is the declaration of what the app needs from the system, so it has its intent processes, the permissions it needs, what the VM will need to know when this app goes to run. Okay. Classes.dex, which is all the compiled Java code put into one file. Resources, which has like images, anything else that's packaged that's not code in the application. Lib, and then the meta-inf. The meta-inf directory stores checksum information when the APK is signed. So how are we going to take this .dex file, which is more or less just text, and turn it into something a little bit more readable? There's two tools that are typically used, APK tool and backsmalling. When you run these tools against the APK, you'll end up with a whole bunch of .smally files. Here is an example of going through and using APK tool. So we're going to run APK tool D for decompile, and then go through, decompile and build a resource table, and then turn stuff into Smalley. Load the resources, do method matching, all sorts of fun stuff. These are the directories that are created once you run the tool. So the Smalley directory will actually contain all the Smalley files of the application. So here's just a quick example of the small files that are created. Now the Smalley files they'll loosely match back to the original Java source code. It's not one-to-one, not like one Java source code file and one Smalley file. Sometimes they're broken up here and there. But the names of the files will tend to correspond to the appropriate thing for how it's written originally in Java. Okay. So when we're done decompiling and doing all sorts of fun stuff with the APK, we then build the APK back up to push back on a device with our lead hacks, modified code. Okay. We would run an APK tool. Oops. Okay. APK tool B for build. And then we go through and then build the APK. Now, the important part about this step is that the APK is not signed at this part. So it's still just a plain APK. And on Android, you need to have a signed package to be installed onto the device. It doesn't have to be a trusted cert, it just has to be signed. So this is just a quick example I pulled off the web of how to create cert. If you don't have the SDK installed, and then how to sign the APK. So you create the cert with ptool, which is a Java tool from the Java SDK. And then jar signer is also in there, allows you to sign the APK. Jar signer is also used to sign jars. So, similar process. Okay, Cydia. Has anyone here heard of Cydia Substrate? Awesome. So, of course, this comes out like 2 months after I first gave this talk. And I was like, damn it. So, what we've been doing before when we were assessing Android applications is when you decompile it, mess with the code, compile it back, put it back on the device. The problem with that is you end up with a different signature of the APK than when you originally started. So if the app is doing signature checks for permissions or other apps are checking the signature of that application, it raises a whole new level of complexity and it's just a complete pain in the ass. So what Cydia comes out and lets us do is actually do runtime manipulation of the Android package. So we can write something that will manipulate the package at runtime so we don't have to decompile it. Well, we'll always have to decompile and figure out what's going on. We don't have to recompile it and push it back and have it be a different image. We also use this for reusable code. So if there's something that we're going to do every time, or we see it multiple times when we're assessing an application, we'll write a Cydia Substrate extension for it, because then we don't have to keep doing something through the APK. We have it loaded on our devices, and it goes away. So it's actually really cool to hook methods as they're running on the fly to change variables and make the application do what we want without modifying the code directly and without breaking signature checks on the APK. Alright, so now let's go over. So we got to the Smalley files. Let's talk about how to read them a little bit. Alright, so Smalley again, disassembled X. And it is not as scary as x86 assembler, nor is it as scary as Java bytecode. What the Smalley ends up being is ASCII representations of the Java opcodes. And like I said before, it loosely corresponds to original .java files. Right. When you're going through with the different methods and variables, there will also be types that will be assigned to them as you're going through and looking at the code. So here's just a table showing all the different types and what's represented as. So voids are V, booleans are Z's, bytes, B's, shorts, S's, chars, C's, ins, I's, etc. Alright, this is a hello world example I took from the Smalley project page on Google Code. And we're going to use this to step through and figure out what's going on here, what these different pieces do. And we learn what each instruction is supposed to be doing. First thing is the variables. There are registers and parameters. And the registers are the variables defined within the code. So you'll see V0, V1, etc., all the way up in the code. Those will reference variables that are used by the application. We then have parameters, and those are defined at the beginning of the function in the method declaration. And those are the parameters that we passed into it, and they'll be referenced as P0, P1, etc. going through the code. And both of these are defined at the beginning of the method. So if we go back to our example here, this says it's going to be 2 registers. So there's 2 variables that are going to be coming in that we're going to be using. We have V0 and V1. Alright. If we want to put information into a variable, we use a const command to put that value into the variable. So if we're just doing integers, we'll have const for strings, const string, and then there's a whole slew of them for the different type of variables that there are. So here are 2 examples down here. When you do the const for just an integer, it ends up going in as a hex value, so you have to do the hex value of integer, and then the string will just go into quotes. So we go back to our example, we're just saying hello world, const string, hello world. Calling methods. So you'll have to call different methods within the program, and those are done via invoke statements. So we have invoke static and invoke a virtual. Going down here, it's going to invoke the virtual for the print stream, print line, and we're going to pass into it the hello world variable as the v1, and that will then print hello world to the console. What's not that example, what we're going to see later on, is conditionals. You don't end up seeing actual loops. There's no for or while in Smalley. You'll end up just seeing a bunch of ifs and go-to statements. And the ifs will move the flow of the code. So I listed a couple here. There is the if equal, if not equal, if equal to 0, if not equal to 0, there's greater than, less than, etc. What you would expect to do in programming. After the if statement, there will always be a condition that will say where I'm going to jump to if this is evaluated to true. And then that label would show up later in the code. So here's an example. These aren't, actually I should have had a line numbers there. These aren't programmatic, they're not actually in line. The stuff down here is on a way separate line. So we'll see that if not equal to 0, so it runs this command, moves the result to V0. And if V0 is not equal to 0, we're going to move to condition 0. So down in the code, there will be a condition 0, which again, zeroes it out and then goes to a different go-to to jump to a different part. Get that? So there will be static variables or global variables defined at the beginning of the function. And this is where get put comes into place because these variables we reference throughout the code. Just 2 examples here. IPut will put the value into, figure out my buttons here. So this will put the value into the order table, and then IGet will read the value from the fiction F and assign it into the V0 register that's being used throughout the code. Every function is going to end, so it's going to return. We have a couple return types here. This is the most, the common ones that I see is return void. With the function's void, it's always going to return void. Return object, if there's something more complex, like a hash map or something, it's going to push back. And then a return and just a variable, as though it is an integer or a boolean, you'll see throwback. Alright, let's get into a couple case studies here. After we look at this code, think about some fun things we can do with some apps that we pulled off the market. Alright, ads. Who here likes ads in their Android app? You would. You probably click on there too, don't you?
I support programmers.
Get some hate here. What's up with this? Alright. So I don't like ads. I find them annoying. I block plus on the browser, everywhere I can turn off ads, great. So they take up screen real estate, they get annoying, sometimes they make noise and yell stuff at you when you're trying to do stuff. It's very intrusive when I'm trying to play games. And also my 4-year-old doesn't know to not click on that. So give them an app, and sometimes it's a little questionable, I only can click on the ads, or also it's like, oh here daddy, look at this. I'm like, oh my god, what you do? Yeah, so we gotta turn that stuff off. And I don't want to turn my radio off, because I still want to get alerts on my phone, so I don't want to turn the radio off, so what am I going to do? Let's get rid of these ads. Alright, I like to play solitaire. My son doesn't like to play solitaire, but I like to play solitaire. So, with this one, when you would do a deal. The ad video would show in between each deal. So you deal a new game and then the ad would come up. At first it wasn't very intrusive, it was like a picture, singles, click here, download this app, vote on us here, the normal developer stuff. But then it started making noise. And then I started having videos and vibrating my phone to get me to go to some music thing. I'm like, no, F this, I don't want this. Let's stop that. Alright, let me show you. No, I don't do live demos anymore because they never work. I have never done a live demo, even in 2600, they fail every time. I can't do live demos, so I pre-record my demos because that's way easier. Can you guys, you have to see the details, you have to see the deals it goes through. But I have to lean over here. There we go. Okay. So we're gonna go through, I'm gonna call up the solitaire game. There's already a game there, so I'm just going to go and then bring up the deal and start a new one. See? Damn it. And that's not even one of the more annoying ones. But the annoying one is it makes you, I have to actually tap on the screen to bring up that menu at the bottom to get out of the ad. And you can only do that after you've been in the ad for 3 seconds. So in between each deal, I'd sit there for 3 seconds and then tap it. It wouldn't let me do it before. And then if it was I had this one video one show up and it took up the entire screen, so when I tapped on it, I wrote on that page. I was very good at it. Slideshow. Okay. So I was looking through the code. I was gripping through the code for the word ad. That was really hard to do because AD is a very common combination. So I did stuff like display and call and add control. So after an extensive search, I found this piece of the code in one of the small A files and it was calling a nice function called display add. Wonder what that does. Hooray, descriptive function names. So let's just comment that out, right? It's not going to call the add function at all. So you put a pound sign in front of it and it turns into a comment, right? Right, so after the change was made, I went through, recompiled the APK, reassigned the APK, and then since there were 2 programs called the same thing, can't have that. So I removed the old one and then I installed my new password one. Alright, so, want to see that in action? Well, you're going to it. Okay, so I'm going to bring back up solitaire here. Middle of the game, I was losing anyway, so screw that game. No ad. Let's do it again just to be sure, right? And my radio is on. I should have shown. I probably saw it earlier. But the radio is on, the radio is not off. And again, no ad. Hooray! No more annoying ads. Okay. So, what if the ad doesn't just display during the middle of it? What if it's not that easy to do? What if it's one of the ones that just sits there on the screen, and just is there the whole time, mocking you, supporting developers at the same time?
They have to eat.
They do have to eat, yes. Well, then they should charge for their apps. I'm not against charging for the apps. I'm against intrusive ads. It's freeware stuff that still sells itself.
They also leak personal information, clear text over your network.
Oh, yes, they do that too. So there's privacy involved. So yeah, how about that? You want?
There is web projection, like in JavaScript bridge. Oh yeah, that's great.
Yeah, exactly. Let's just have remote command execution on all of our phones. Yes. So obviously, when you disable your network, the ads don't work, right? Because it can't pull it down. So what if we could mimic this function in the code and force the APK, the program, to think that it doesn't have network connectivity, right? That'd be pretty cool. So playing chess also. Play chess with my friends by myself. I play a lot of games by myself. Solitaire chess. I don't know this is. So it's getting in the way of my game, right? That's annoying. So the cool thing is Google actually has its own ad network and its own ad APIs that a lot of developers use. All right, that's really cool. They all rely on network connectivity, and most of them rely on this one API. Fantastic. So if we find a way to break it in one app, we can break it in multiple apps, right? I know now what to do, either doing Spring or using Cydia substrate, to disable ads in a lot of packages that are out there, right? So what I did is I turned off the radio and then fired up the app and watched the log. And then luckily it spit out an error message when it didn't have connectivity. Error message at the bottom, ad request web view was no while trying to load ad. Fantastic. Now I just correct for that in the code. And I come up with this. So looking down to here, that's where the string goes. So here's the conditional before it. No, this one there is. Okay. So it tries to call the ad. If it's equal to 0, which means it was false, it jumps to condition 0. Condition 0 says, okay, couldn't load the ad, no network, I'm now going to skip on that and continue doing what I'm doing, right? Alright, so let's just force the v0 variable to always be false when going into this condition. So no matter what this returns, which in this instance it still loads the ad because the ad is actually being called. I'm just faking out the first function. You could go back and mess with this function too, but I found this one first, so that it worked, right? So I haven't solved the privacy, but I solved my screen real estate issue. So v0 will always be 0, so that conditional will always be met to jump down to the conditional that will throw the error message. And now here's a screenshot of playing chess without the ads. Fantastic, right? Alright. Pinball. Another game I'm playing by myself. But this one has internet connectivity with scores. So getting a high score is pretty cool, right? Showing the leaderboards, like how awesome you are, and brag to your friends, look at this great score I got, right? So how would we manipulate this? You could manipulate the physical database, but I want to always get high scores. The point values for the bumpers and the different parts of the code, or the parts of the pinball table, are probably in the code somewhere. Let's try and find them. So here's can you guys see the number at all? It worked last time, but not this time. I did lighten it, and it worked at DerbyCon. I apologize. So after playing one, normal game of pinball, I came up with a measly 186,086 points. Right? Not a lot. Pretty lame. Yeah, sad. And so when I was watching the game, and I was watching it when the ball hit a bumper, what the score went up by. And I saw at some points it was going up by 50, sometimes going up by 100, 150, so it depended upon how difficult it was to hit that particular item. So I converted those values to hex and then wrapped the code for those values. And I came up with these. So this is the value of one of the bumpers, and here's a different value, right? Okay, great. Now I know what I'm going to manipulate to get high scores constantly, right? All right. So let's just make them all Fs. Just gotta, max this thing out. I, maybe a couple Fs, and then a couple things here and there to mess with it. What's really difficult about this is the score is actually, it's an integer. So when you start hitting like 4 or 5 Fs, and no matter what you're doing, throwing a couple 100,000 at it every time, yeah, they know where I'm going, right? Max int in 2 seconds. So the ball would go up, it would hit a couple bumpers, hit max int, and then the score thing would just mess up. And blink a couple times, it would go to 0 and die, I'd have no score because it just messed up that area of memory. So I had to scale it back so that I could actually complete the game. without the score being wiped out, because I wanted to show my friends who go on the internet and be like, look how awesome I am, hooray! So that wasn't showing either. Man, I apologize for this. It might be because it's a backlit one, because it was working at the conference just fine, I apologize. So in this one, I have 654,311,360 points. After just letting the ball go up, hit the bumper a couple times, and then successfully do that to end the game. What was also difficult about this is that the game was kind to the player, so if you launched the ball up and it just came back down with hitting like 1 or 2 things, it would give you a free ball. So I'm sitting there just like trying to get barely to hit something so that I could actually finish the game to have the score go on the internet. So what happens when a score goes on the internet? Number 1. It's not the same score. I had another one because there was slides a while ago, and this one was recent, so I had to redo a whole bunch of stuff. So this score isn't as impressive. It's only a 211 million, as opposed to my 600 million that I had before. What was interesting about this is the other people must have either figured out how to change max int to, well, not change max int, but change the values and not be an integer. And then also, or probably intercepted the traffic, because the dudes in the global, like I was still like number 300 in global, even with that high of a score. There's like, they're really good at pinball. They found a way to get past max int because the values they had were way over max int.
You're saying they're pinball wizards.
Pinball wizard. So that's what happens with the leaderboard. Alright, so what now? So I brought you through how to read the code, how to mess with the code, and then a couple little examples with this. You know, and what we do, this comes up a lot when we're trying to bypass stuff or get information out of an application. If it's not logging something, we really want to log it before it's to log it. Or if MDMs are doing like group detection, yeah, that's a value client side. Can you trust stuff from the client? No. So that's pretty easy to get past too. So that's some stuff when you go through app assessments to continue on. So I hope you guys go out and explore. Yeah, I was one of the last talks, so I figured scale back a little. You guys want to go out and eat and go back to drinking, right? Yeah. See?
Do it.
So here's a couple references. The first one is Dalvik opcodes. So there's hundreds of them, not just the ones I've shown you. Not all are used, and some are really obscure and weird. So the whole list is there, and that's a good one because it actually gives examples. The one that Google links to doesn't give examples. It just says this is a const. So, what the hell do I do with that? And then the bottom is also APK tool. It's a command line tool to use for this. So I'll take a couple questions if people got it, except from that room. You guys are not allowed to ask questions. No? Okay.
Examples of how you would use that in your app assessments.
Yeah, so if the application is doing something we want to get around or force a certain behavior to always happen, we'll do that. Like I was mentioning, MDMs, force it to always say that, yeah, device is not rooted. Okay, yeah, because you can trust it, right? Also getting information out of it. So if there's a value that's not being stored to a database or you want to see what's going on in that piece of code, you can force that value to be output as a log file. So that's a couple things.
CDS substrate is same as mobile substrate?
Yes. Yes, it's written by CERN. It's in the Play Store. You have to have a rooted device. And it actually injects into the libraries for Dalvik. Yeah, it's made a lot of things really easy and repeatable and cool.
Is there questions and comments?
Anyone else? Alright, I'll be around all weekend. This whole row is here is people I work with from Citadel, so we all do a lot of mobile stuff, a lot of cool stuff, so come over, say hi. We got a booth over there by the vendor area. You guys want to come over, say hi? We're hiring, which is cool. What's that?
And drinking.
And drinking, yes. Drinking at 10:30 in the morning. That was It's still drinking. Hey, we're gonna go on to eat soon. Finish up this.
Drink tickets?
Oh no, we're not that high of a vendor. Sorry, we're silver. They didn't give us any drink tickets. I'm sorry, I haven't passed it out or use them all myself. Hey, Michelle's the sponsor instead of not me. Okay, so take it up there. All right. Well, thanks, guys.